Hi, Assalamualaikum. Today we will be presenting our group project for the subject MAT 222, which is Mathematical Logic and Proving Techniques. We are from class JCS 1433F and we are group 4. We chose our topic, which is Laws of Logic. Here are the group members. We have HASHILAH AMIRAH binti HASHIM, NURUL AMYLIANA binti ZULKEPALI, ANISA SYAHIRA binti LOKMAN, and EIZYAN NADJHA binti MUHAMAD ZAHIR, which is me. Here are the table of contents. First one, we have introduction. Number 2 until number 4, we have the content of the table for law of logic. Number 5 until number 8 are the examples. Lastly, number 9, we have conclusion. For introduction, a large truth table will be generated if we are given a long statement or a statement that consists of more than 3 primitive assertions. This is an example of a truth table with 3 primitive assertions. Now, as we can see here, it's already big enough. If we insert one more primitive assertion, it will be longer and bigger and it will take a lot more time. To avoid this, we can use the laws of logic, which are a set of rules that can be used to construct logical equivalences. Here are the table for the laws of logic. The content of this table will be explained by the other members.
Hi, let me start first. Did you guys still remember the first law we learned in this subject, which is the law of the set theory? Okay, in this subtopic, we still use the same law, so you should be proficient in using all these laws. First, the law of double negation. In this situation, can you see the double not sign here? Okay, if there are double sign of not, which is not P, it is actually logically equivalent to P. The second is De Morgan's law. Okay, the function is the same in the topic laws of set theory, which in this case the not sign multiply for each set, but please be careful with the logical connective. If the original sign is OR, then the new one will become AND. It will happen otherwise. The third law is commutative law. This law is represented to change the position of the set. Next, associative law. The function of this law is to change the position of the bracket. But in this case, the sign between the set has to be the same. So please be careful whenever you want to change the position of the bracket. The last law that I want to share with you guys is distributive laws. To apply this law, whether you expand the set or like you factorize it. As you can see here in this table, these are examples of this law. If your statement is just like the right hand side, so you can solve it to the left hand side, and also it will happen otherwise.
Next, I will explain few law of logic, which are absorption law, identity law, inverse law, and domination law. So the first one, absorption law. The first example, P or P is equivalent to P, while P and P is also equivalent to P. Whenever we see the same variable with there are the same sign in front, which this one there are no not and this one also no not in front of the P, it will get the same variable itself. And the next one, identity law. The first example, P or F is equivalent to P. P and T is equivalent to P. The next one is inverse law. Inverse law, P or not P is equivalent to T, while P and not P is equivalent to F. This one is different with absorption law. Absorption law, there are the same variable. Inverse law also got the same variable, but it has different sign in front, which is there are no not here, but there are not P over here. So when we get the same variable but different sign, we need to use inverse law to simplify. And the last one is domination law. For the first example, P or T equivalent to T, while P and F is equivalent to F.
Hi, okay, so now I would like to explain about three laws of logic. First, absorption law. Second, definition of implication. Third, contrapositive law. For absorption law, if our statement is A or open bracket A and B close bracket, it is equivalent to A. Why? Because we have same variable which is A whose position is next to each other, and also we have two different signs which is and or between the variable of A. So let's see to another example. If our statement is B and open bracket B or A close bracket, it is equivalent to B. Why? Like I said before, we have same variable which is P whose position is next to each other, and also we have two different signs which is and or between the variable of P. So now we move to next laws. If our statement is if A then B, we can use either two laws, definition of implication or contrapositive law. For definition of implication, if A then B, it is equivalent to not A or B. For contrapositive law, if A then B, it is equivalent to if not B then not A. So now I want to share with you how to write a contrapositive law from if A then B to if not B then not A. First, we need to change the position of A and B. Second, we need to add not to the both of the variable. So this is how we can write a contrapositive law.
Hi, it's me again. Okay, let's proceed to the first question. The first question is to simplify this statement. Okay, to solve this question, it is easier for you to solve it using a table. Did you guys see the not sign outside the bracket? Okay, to solve this question, you have to solve it by expanding it. Then it will become like this. Then actually the law that we apply in this statement is De Morgan's law. Next, there's a double not sign here. So you have to apply the law of double negation, then it will become like this statement. Okay, as you can see from this statement, there's no other way that we can explain it or make it disappear. But please watch carefully. This sign is actually logical connective OR, and also this one. So we can apply distributive laws. So your new statement will become like this. Since this statement becomes like this, can you see these two sets? Okay, let's go back to our table law of logic. As we can see here, law number 8 shows that the same statement, so that we can apply this law, which is inverse law. So the answer that you will get is set P or contradiction. This new statement, you have to check based on the table. It looks like the same as law number 7. So apply identity laws, then you will get your final answer.
So for example 2, which is proof if the statements are logically equivalent with each other. So here is my example. Usually we will do the left hand side first. So there's not much that we can simplify except for distribute. So we will distribute Q with the one inside the bracket. So we'll be using distributive laws. It will become Q or not P and Q or not Q and Q or R. So for this one, we can see the one inside bracket here. We have Q or not Q. From that one, we can use inverse law and it will become T right there. After that, we can change the position of the bracket, which we will be using associative laws. So from here, we will change the bracket so that it will close on this side. So we will be having Q or not P and T. And from this, we can use identity laws because we have T right here. So from this one, we will be getting Q or not P. Now from this one, when we look at the statement as a whole, we will be living with P or Q or not P and Q or R. So from this one, we can use distributive laws again. So we will be distributing between the P and the one inside the bracket. So we will be living with P or Q or not P and P or Q or R. Next, we will continue from the distributive laws. So after we had distributed, it will become like this. Next, we will change the position of the words here, the primitives. So we will change the position, so it will become like this. The not P will be in front and Q will be at the back. From this one, we will be using commutative laws. After that, we will change the position of the bracket once again. The bracket right here, we will change into here. So that means we will be using associative laws. From this one, as we can see here, P or not P, we will be getting T here. So that will mean we use inverse laws. And then if we see here again, T or Q, that means we can use domination laws, and that we will be living with T. After that, we will be left with T and P or Q or R. For this one, we can use identity laws. So it will be left with P or Q or R. So we had gotten this statement right here. So we can see if the statement are logically equivalent with each other, and it is.
Next example, show that P implies open bracket P or Q close bracket is a tautology by the law of logic. So the first thing we need to do is we need to change the implies error to a symbol like this symbol, like OR symbol. So the first thing we need to do is we need to use definition of implication, which is we need to add not in front of P and change the implies error to OR symbol. So it will be not P or open bracket P or Q close bracket. So we can see that there are two same variable, but these have not P and this one is only P variable. So what we need to do is we need to combine these two using associative law. So it will become open bracket not P or P close bracket or Q. So not P or P is P. So this is by using inverse law. Whenever we see not the same variable but different sign over here, there are not P and this one does not have not P. So we need to use inverse law, which is the answer will be equivalent to P or Q. So next, we know that P or Q is equivalent to T with using the domination law. So the final answer will be T. So since the final answer is T, we can conclude that P implies open bracket P or Q close bracket is a tautology.
Now we move to our last example. Show that open bracket A and not B close bracket and open bracket A and B close bracket is a contradiction. Okay, first we need to construct a table. Second, we must make sure that our last answer must be F to make sure that our statement is a contradiction. Okay, our first step, we can use commutative law to change the position of variable A and B. For example, open bracket A and B close bracket to open bracket B and A close bracket. Second, we can use associative law to change the position of bracket. Why? Because we have same sign between the variable n, n, n. So now our new equation is A and open bracket not B and B close bracket and A. Next, using inverse law, we know that not B and B is equivalent to F. So now we have A and F and A. We can choose if we want to use A and F or F and A because the answer will be the same. Let's say I choose A and F. A and F is equivalent to F using domination law. Lastly, our equation now is F and A. Using domination law again, F and A is equivalent to F. To sum up, our last answer is F. Then we can show that open bracket A and not B close bracket and open bracket A and B close bracket is a contradiction.
In conclusion, law of logics are used to avoid using big and long truth table. Like what I had briefed for introduction earlier, using law of logics will make it easier for us when we are given a long statement or statements which have more than 3 primitive statements. That is all from us. We hope our videos benefit to those who's watching. Thank you.